Good afternoon. Good afternoon, everyone. Good afternoon, everyone. So, first of all, as a small check, just let me know if my voice and video is visible to you, please. All right. Thank you so much. So, today we are going to start with monotonicity. Anybody facing any issue in tangent normal questions and something, please go ahead. Let me know. Or else we are going to start with monotonicity. Now, monotonicity is what? It is a same kind of behavior of a function. Got it? So, take it like if a function is always increasing or if a function is always decreasing, we call it a monotonous function. What do we call it? Monotonous function. Okay. So, a line is there. If functions are said to be monotonic if they are either increasing or decreasing in their entire domain. Am I clear? For example, e to the power x. If you remember, the graph of e to the power x is like this. Like this. Got it? So this function is always increasing. Am I clear? Or say fx equals to ln x. The graph of ln x is like this. This function you see, this is also increasing. Got it? Or fx equals to 2x plus 3, then it will be like this. Like so, they are always increasing. Okay? Or there are certain functions which are always decreasing. Like if I talk about fx equals to minus of x cube, the graph will be like this. Like this. This function is what? Always decreasing. Or if I talk about fx equals to cot inverse x, graph is going to be like this. Always decreasing. So this is how we see a function is always increasing or always decreasing, then those functions are called monotonic functions. Have I made my point clear? Now there are certain functions which are increasing as well as decreasing in their domain. Like if you see sin x, or if you see ax square plus bx plus c, or if you see mod x, they are increasing as well as decreasing. So those functions are not called monotonic. They are sometimes increasing, sometimes decreasing. Now, monotonicity of function, how do we judge it? This is the basic definition I'm going to tell you. It has no flaw. So, if f of a plus h is more than f of a, what is this? See, this is the graph of a function. This point is what? X coordinate a, y coordinate f of a. This point is what? X coordinate a plus h, y coordinate f of a plus h. Here x coordinate a, y coordinate f of a. This point is what? A minus h, f of a minus h. Now you can clearly see if it is an increasing function, then f of a plus h will be greater than f of a, and it will be greater than f of a minus h. F of a plus h is greater than f of a, which is further greater than f of a minus h. So this is the very basic definition of increasing function. When everything fails, this will give you correct answer. Got it? Yeah, so this is mentioned here also. A function is said to be monotonically increasing at x equals to a if it satisfies that f of a plus h is more than f of a and f of a minus h is less than f of a. Am I clear? Now, same thing for the decreasing function, but now what will happen? F of a will be greater than f of a minus h, sorry, will be greater than f of a plus h, and it will be less than f of a minus h. Got it? So f of a plus h is less than f of a minus h is greater than f of a. Got it? Now, one very important thing, it should be noted that we can talk about monotonicity at x equals to a only if x equal to a lies in the domain of the function. So if a function means if definitely it is not only about x equal to a, about any behavior of the function, we will talk about at a point only if it is in the domain. If that point is not in the domain, there is no point of discussion at that point. Am I clear? No point of discussion of the monotonicity at that point. So we can discuss about any trait of a function only if it is in the domain of the function. Got it? Now see, these are simple figures. In this diagram, if you see, this is going to be next point a plus h. This is going to be a minus h. So it is very much clear f of a minus h is less than f of a, which is less than f of a plus h. Got it? So this function is increasing at x equals to a. If you see in this diagram, definitely next point is lesser, previous point is greater. Do you see that? Next point having lesser value, previous point having greater value. So it is decreasing at x equals to a. Got it? Now if I see here, okay, say at x equals to a, say at x equals to a, this is the value of the function. So easily you can judge that f of a plus h is greater than f of a and f of a minus h is less than f of a. So means what? This function is increasing at x equals to a. Am I clear? Function is increasing at x equals to a. Here also function is keep on increasing. So this is also increasing at x equals to a. So this is the totally basic definition. It does not have any flaw. It is not required here that the function should be derivable or should not be derivable. Got it? Now see, one or two example if I show you. Say this. Got it? What should I say? See, f of a is greater than f of a plus h and f of a is also greater than f of a minus h. Yes or no? Left value is also lesser, right value is also lesser. So non-monotonic at x equals to a means neither increasing nor decreasing. But if I make the graph of a function like this, see, here it is increasing, here it is decreasing. But what is happening at x equals to a? F of a minus h in the left of a, it is less than f of a, and f of a plus h is more than f of a. Next value is greater, previous value is smaller. So function is what? Increasing at x equals to. Got it? Now, how do we check about the increasing and decreasing of a function? So, first of all, see, I will show you here. Say this is an increasing function. On this function, there are 3 points. Say x1, x2, and x3. So coordinate of this point will be what? x1 comma fx1. This point is what? x2 comma fx2. And this point is what? x3 comma fx3. Now if you see, x1 is less than x2 less than x3. x1 is less than x2 less than x3. So it is very much clear that fx1 is less than fx2, which is less than fx3. So if an increasing function is applied to an inequality or it is removed from an inequality, the sign of inequality does not change. Got it? Either you do this way or you do this way. Either you apply to increasing function or you remove an increasing function, the sign of inequality does not change. Whereas, now see, let us assume this is a decreasing function. This is x1, x2, x3. So this is x1 comma fx1. This is x2 comma fx2. And this point is x3 comma fx3. Now if you realize x1 is greater than, x1 is less than x2, which is less than x3. Whereas fx1 is the largest one. x2 greater than fx3. So that means on an inequality, if a decreasing function is applied or already applied function is removed, on an inequality, if a decreasing function is applied or already applied function is removed, the sign of inequality changes. Getting my point? The sign of inequality will change. Am I clear? So this is what we are also saying here, that said to be increasing in a to b. If x1 less than x2, then fx1 less than or equals to fx2. Got it? Now what will happen? If a function is increasing, if a function is increasing, that means f of x plus h is more than fx, which is more than f of x minus h. Now, what is the definition of f dash x do I have? That is limit h approaches to 0, fx plus h minus fx upon h. So, see, since fx plus h is more than fx, this numerator is going to be positive. And denominator h is very small positive quantity. So f dash x is going to be 0. Similarly, if I check for the left hand derivative, limit h approaches to 0, it is fx minus h minus fx upon minus h. Now, from this point of view, if you see, numerator is going to be negative, denominator is also negative. So this ratio is still positive. So if fx is an increasing function, means its derivative is always going to be more than 0. If a function is always increasing, its derivative is going to be more than 0. Got it? Derivative is going to be more than 0. And similarly, if fx is a decreasing function, its derivative is going to be less than 0. Am I correct? If fx is a decreasing function, its derivative is going to be less than 0. Now see, let's see one or two examples first, then go forward. Find the interval for which this fx is monotonic increasing. Fx is increasing. So first of all, what you will do, you will find f dash x. F dash x is going to be 4x minus 1 upon x. F dash x is going to be 4x minus 1 upon x. Now, what do we want? For the function to be increasing, it should be more than 0. So it comes 4x square minus 1 upon x greater than 0. Am I clear? Now this numerator can be written as 2x minus 1, 2x plus 1 upon x greater than 0. Now we have learned about the Variker method. So mark all the zeros here, minus 1 by 2, 0 and 1 by 2. Mark all the zeros in their increasing order. And now if you see, this is the graph. So plus, minus, plus, minus. What we are looking for? Positive. That means x belongs to minus 1 by 2 to 0, union 1 by 2 to infinite. So this is the interval where a function is increasing. Got it? Have a look at it. Derivative we figured out, and then we made the derivative positive to find the interval where function is decreasing. Now, definitely in the rest of the interval, function is going to be decreasing. So decreasing in x belongs to minus infinite to 0. Sorry, minus infinite to minus 1 by 2. Union 0 to 1 by 2. All right. Anybody facing any problem? Well, next. Find the interval of monotonicity for the following functions. Now see, fx is given to you as x to the power 4 minus 8x cube plus 22x square minus 24x plus 7. Got it? If I find f dash x here, it will be 4x cube minus 24x square plus 44x minus 24. If you take 4 common, it is x cube minus 6x square plus 11x minus 6. Got it? Now I got a cubic here. The factors of this cubic are 1, 2, 3. It's very standard. You can remember this cubic if possible. So it is 4 times x minus 1, x minus 2, x minus 3. Correct? 4 times x minus 1, x minus 2, x minus 3. Now, again same 1, 2, 3 and make the wheel. Plus, minus, plus, minus. Got it? What we are looking for? Increasing. Increasing means if we are looking for increasing function, means interval where f dash x is more than 0. So it is more than 0 in 1 to 2 and then 3 to infinite. Got it? So implies x belongs to 1 say 2 union 3 say infinite. Now decreasing if f dash x is less than 0, means x belongs to minus infinite to 1 union 2 to 3, where derivative is going to be negative. Got it? So this is how we check for the increasing and decreasing behavior of the function. Now see B part. Say fx equals to x ln x. What is f dash x? First, into derivative of second plus second into derivative of first is 1. So it is going to be 1 plus ln x. So function is increasing when f dash x is more than 0. Got it? F dash x more than 0 means ln x plus 1 more than 0. Means ln x more than minus 1. So x is greater than 1 upon e. E to the power minus 1, which is 1 by e. That means function is increasing from 1 by e to infinity. Fine. Function is increasing from 1 by e to infinity. Now let us see few facts about the increasing function. If fx is strictly increasing function in an interval a to b, then f inverse exists. Definitely function will be increasing. That means it will be 1, 1. Got it? And on to if we can manage, then inverse will definitely exist and it will also be an increasing function. Now you will say, sir, what will happen to sin x? It is not an increasing function. It is not a monotonic function. Still inverse is existing. Yes, because they have restricted the domain of sin x. Got it? They have restricted the domain of sin x and made it increasing in that certain interval minus pi by 2 to pi by 2. Got it? If fx is a strictly increasing function on the interval a to b such that it is continuous, then f inverse is continuous in f of a to f of b. This is obvious point. Got it? If fx is continuous in a to b such that f dash c is more than equal to 0. For each c belongs to a to b, then fx is monotonically increasing on a to b. This is what they are trying to say. If f dash c is also getting 0, but f dash c is not creating any interval. So function will still be increasing at that point. Got it? This is not a worthy point. Monotonic functions have at most one root. Definitely. Why at most one root? Like cot inverse x is there. This is the graph. It is decreasing, but it is like staying overall above the x-axis. So it won't have any root. But if a function is going from minus infinite to infinite, somewhere it will definitely intersect the x-axis. So it will have one root. So what about the monotonic functions? They are either always increasing or intersecting x-axis at one point, or they are decreasing but lying totally above the x-axis or below the x-axis. Got it? Now, see another simple question. Separate 0 to pi by 2 into sub-intervals into which fx equals to sin 3x is increasing. Got it? So, fx is given as sin 3x. Means f dash x is given as what? 3 cos 3x. So whenever f dash x is positive, function will be increasing. So if this is your f dash x, this 3x will belong to cos is positive in 0 to pi by 2 union. That's it. It happens in fourth quadrant also, but my priority is up to third 3x. So x belongs to what? 0 to pi by 6. That's it. So this is the interval where this function is increasing. It will be increasing further also. Like if you don't finish with this, it will also be increasing 3 pi by 2 to 2 pi. But in that case, this is 3x. X will be what? X will be pi by 2 to 2 pi by 3. So it is exceeding this interval. So that is why I did not consider this one. So this is your only answer. Got it? So fx equals to sine 3x is increasing in the interval 0 to pi by 6. Now, see, there are two theorems, Rolle's theorem and Lagrange's mean value theorem in the syllabus of JEE Mains in JEE Advanced, but they have been like eliminated from the school syllabus. Post-COVID, they have deleted it. Now, what is Rolle's theorem? Rolle's theorem says, if a function f is defined in the interval a to b, if a function f is defined in the interval a to b, it is continuous in the closed interval a to b, it is derivable in the open interval a to b, and f of a equals to f of b. Got it? Means what is happening? Say this is the graph. This is the point a comma f of a. This is the point b comma f of b. Got it? A function is like it is continuous in this interval, it is derivable in this interval, and f of a equals to f of b. Then definitely definitely the point is going to be there where tangent is going to be parallel to x-axis, means where f dash c is going to be 0. So if a function is like a comma f of a, b comma f of b, then tangent is going to be parallel to x-axis at some point for sure. But this may happen with the multiple points also. Like the graph is something like this. Graph is something like this. Then there can be more than one point where tangent is going to be parallel to x-axis. So that is why in the theorem they say there exists at least one real c in a to b where f dash c is 0. Got it? There exists at least one real c where c belongs to a to b such that f dash c is equals to 0. This is Rolle's theorem all about. And they are just explaining this using the graph which I have made. Got it? The theorem simply states that between 2 points with equal coordinates on the graph of fx, there exists at least one point where tangent is parallel to x-axis. Am I clear? Now see a very simple example. Verify Rolle's theorem for the function in the interval 2 to 3. Last line is simply this. The theorem simply states that between 2 points with equal coordinates, on the graph of fx, there exists at least one point where tangent is parallel to x-axis. Now, they are asking for verify Rolle's theorem for this function. Tell me one thing. Fx is given to you as x square minus 5x plus 6. What is f of 2? F of 2 is 4 minus 10 plus 6. That is going to be 0. What is f of 3? 9 plus 6 minus 15. This is again going to be 0. So, f of 2 is equals to f of 3. Since it is a quadratic polynomial, we can directly say fx is continuous in 2 to 3. Then, we can also say fx is differentiable in 2 to 3. Yes or no? That means there must exist c which belongs to 2 to 3 where f dash c is 0. Now let us see. F dash c is what? 2c minus 5. If I make it 0, I get c as 5 by 2. And definitely this 5 by 2 is lying in this interval. Yes or no? This 5 by 2 is lying in this interval. So that means this function is having at least one root in 2 to 3. Got it? Now, since it is a quadratic, we can directly just, there is not at least one, there is only one root. That's a separate deal. Got it? Now, there comes Lagrange's mean value theorem, LMVT. This theorem is almost of same type. First of all, let me give you an essence. Say there is a function like this. Now, in the graph of the function, there are 2 points, say a comma f of a and b comma f of b. Now, you join these 2 points. So, what the theorem is saying, there exists at least one c in interval a to b where slope of tangent is equal to the slope of the chord joining a comma f of a and b comma f of b. So if this is the point C where f dash C is equals to fb minus fa upon b minus a. Got it? F dash C is equals to fb minus fa upon b minus a. Fine. So how this theorem is saying, if a function f defined in the interval a to b, it is continuous in a to b, it is derivable in a to b. Got it? Then there exists at least one real number c which belongs to a to b such that f dash c is fb minus fa upon b minus a. Am I clear? There can be more than that point. Slope of tangent is equal to the slope of the chord joining AB. So if the graph of the function is like this, something like this. This is a comma f of a and this is b comma f of b. So there are more than one point where tangent is going to be parallel to x-axis. Got it? So the geometrical interpretation is simply what I just told you. The theorem simply states that between 2 points A and B on the graph of fx, there exists at least one point where tangent is parallel to the chord AB. That means f dash c is slope of AB. So at least one point will always be there. Got it? Now see the simple example. Fx is differentiable in 2 to 5 where f of 2, f of 5 is given. Then there exists a number c which belongs to 2 to 5. Find the value of f dash c. Now, what did I just taught you? That f dash c is f of 5 minus f of 2 upon 5 minus 2. Am I clear? F of 5 minus f of 2 upon 5 minus 2. So this f dash c is going to be f of 5 is 1 by 2 minus f of 2 is 1 by 5 upon 5 minus 2. So it is 3 by 10 upon 3. So answer is going to be 1 by 10. So there exists at least one c in this interval where f dash c is going to be 1 upon 10. Clear? Where f dash c is going to be 1 upon 10. Okay, let's do a few questions on these topics. See the first one. Fx is given to you as x cube plus 3x square plus 81x plus sine square x. Fx is x cube plus 3x square plus 81x plus sine square x. Check for monotonicity. Check for monotonicity. If the function is increasing or decreasing. Now see how do I do it? Anybody who would like to try? Take a minute. Try it quickly. Tell me if it is always increasing, always decreasing, or sometimes increasing, sometimes decreasing. Yes, anybody? Now see, if I differentiate this, f dash x will be what? 3x squared plus 6x plus 81 plus 2 sin x cos x. Yes or no? So this is 3x squared plus 6x. This 81 ko I write like say 50 and 21 plus sine 2x. Now see one thing. This 21 plus sine 2x. Sine 2x is lying between -1 to 1 for any x. 21 if you add to it, it will be from 20 to 22. Yes or no? And now for this quadratic function, if you check its d is negative. So for a quadratic, if d is negative, that quadratic becomes always positive. So this is always positive. This is lying between 20 to 22, means this is also always positive. Means f dash x is more than or more than 0 for every x belongs to R. And if f dash x is more than 0 for every x belongs to R, this means this function fx is increasing function. This fx is increasing function. Got it? Now say if I ask you fx equals to x square e to the power minus x. Fx is x square e to the power minus x. Now, take a moment, try it. Quickly try. Now see, f dash x is what? First derivative of second minus e to the power minus x plus second derivative of first is 2x. Yes or no? So from this, take e to the power minus x into x common. You are left with minus x plus 2. So it is e to the power x into x minus 2 with the negative sign. Am I clear? Now, the function will be increasing if f dash x is getting more than 0. Means x into x minus 2 should get less than 0. That means what? X lies between 0 to 2. So this is the interval where this function is always increasing. Am I clear? So this is the interval where this function is always increasing. Now let us see another very good example. Phi x is given to you as fx plus f of 1 minus x, and f double dash x is less than 0 in minus 1 to 1. Got it? Now they are asking, show that phi x is increasing in 0 to 1 by 2. Got it? Now let us see, what is phi dash x? Phi dash x will be f dash x minus f dash of 1 minus x. Am I correct? Phi dash x will be f dash x minus f dash of 1 minus x. Now a very important thing that they have given, f double dash x is less than 0. So if f double dash x is less than 0, that means what? If f double dash x is less than 0, that means f dash x is decreasing function. Got it? See, phi x will be increasing if phi dash x gets positive. Means f dash x is more than f dash of 1 minus x. Now f dash is a decreasing function. If f dash is a decreasing function, so when you remove function f dash, sign of inequality will change. So x less than 1 by 8x. So 2x less than 1, so x less than 1 by 2. Am I clear? And x has to be more than minus 1, which is the given interval to be. So that means if x is lying in minus 1 to 1 by 2, phi dash x is going to be more than 0. So phi x will be an increasing function. They are asking for 0 to 1 by 2, it's fine. Got it? But yes, one point is clear that your phi dash x is more than 0 if x lies in minus 1 to 1 by 2. Is this fine with you? Got it, guys? Well, anyways, that would be